Waste and environmental management is a critical part of battery recycling laboratory safety. It is not simply a post-experiment cleaning task, it is directly linked to safety, compliance, and environmental responsibility. Solid, liquid, metal-bearing, corrosive, and damaged battery waste streams can create serious hazards if they are mixed incorrectly. Therefore, this presentation focuses on waste stream separation, suitable container storage, traceable documentation, and safe transfer to licensed contractors. A common mistake is treating waste as unimportant residue after the experiment is finished. In reality, many laboratory accidents occur because waste is placed in the wrong container, labeled incorrectly, or left in an unsafe area. In battery recycling laboratories, this risk is higher because waste streams may be corrosive, metal-bearing, conductive, reactive, or energy-containing. Therefore, waste management is not the final step of safety culture, it is a control area that continues throughout the process. Segregation is the basic principle of waste management. Its purpose is not only to keep the laboratory organized, but to prevent waste streams with different hazards from interacting. It also supports recycling efficiency. For example, black mass and acidic filtrate must not be managed in the same way. Similarly, a damaged lithium-based battery and an intact waste battery should not be stored in the same container. Waste segregation is not only an environmental task, it is a laboratory safety responsibility. Containment is the physical safety dimension of waste management. Having a container is not enough. It must be suitable for the hazard characteristics of the waste. A container used for a corrosive solution may not be suitable for dry conductive particulate waste. Secondary containment is also essential, because it provides a second barrier against leakage or spread. Containment should not be understood simply as storage, but as a safety control strategy. Traceability is the documented form of safety in good laboratory practice. If the content, generation date, responsible person, or final destination of a waste container is unknown, that container becomes a safety uncertainty. Traceability supports both internal and external inspection. More importantly, if an incident occurs, it helps reconstruct the chain of cause and effect. For this reason, labeling and record keeping are not bureaucratic tasks, they are safety mechanisms. In a battery recycling laboratory, there is no single category called waste. Different streams require different safety and management approaches. A damaged lithium-based battery cannot be handled in the same way as a metal-bearing acidic leach solution. Similarly, black mass may be a process material or a waste-type stream, depending on the context. Safe environmental management begins with the ability to classify waste streams correctly. The final stage of waste management is contractor handoff, the safe transfer of waste to an authorized recipient. Good segregation and containment inside the laboratory lose their value if the waste is transferred incorrectly. Before transfer, container suitability, label accuracy, record completeness, and chain of custody must all be checked. This helps students understand that the laboratory is not a closed system, but part of a broader environmental management chain. Waste and environmental management are central safety topics in battery recycling laboratories. A safe approach depends on proper waste segregation, suitable containers, accurate documentation, and traceable transfer to an authorized recipient. This approach supports environmental responsibility, reduces operational risk, and strengthens professional laboratory practice.